Welcome back. Hi everyone. So today I'm going to show you how to make a subset of a NetCDF file. If you have a NetCDF file that is covering the wide area, and if you want to convert it to a smaller area, right? If you want to cut the values and the data for your study area that was previously pretty big, and you were not able to even process all these things because you may be out of your computer memory and every other thing. It will take a lot of time to process the entire file, and basically we don't need that, right? So that's what we have to do. In order to make the process faster, we have to make the subset of the data. So let me quickly show you how to do that. If you are familiar with Python programming, you can do that, and even by this time you know, right, how to read NetCDF file. If you don't have that idea, so I have another video where I already demonstrated that how to read a NetCDF file. It is pretty easy. It is not that hard. You can just use one module called NetCDF4, and then you can easily read the variables, or you can use Panoply to read the variables, right? And then you can call those variables by their name, right? By their names, and then you can even use the subset. But in order to make a subset, you have to have the coordinate, right? Your boundary coordinate. You can do that, you know, right? If you have any GIS shape file, you can make that corner. So I'm going to show you how to do that. At first, let me just show you the box, right? The boundary box, or the bounding box. So here it is. I'm sharing my screen right now. So that is the code. Before going to that code, okay, I'm going to show you based on that one. Okay, if I want to extract the data, and before that, I'm going to show you using Panoply, okay? Because I already mentioned that Panoply, that what I have, right? The extent of the data. At first, you have to understand if it covers this area, then definitely we can create that subset. Otherwise, we won't be able to do that. So we have that Panoply there, and I'm opening that wind and pressure field. We can open any NetCDF file. So that's that. I'm gonna, okay, just plot the pressure plot, just only to see the extent of the data, nothing else. So let's see. See, it's covering the entire USA, right? Part of the USA and part of the Atlantic Ocean, but my study area, that is locating there, right? It is somewhere there, not there. It is there in Texas. Okay, so yeah, definitely it will cover, no worries. So we'll extract the stream flow, not a stream flow, that precipitation. If we have stream flow from National Water Model, we can even make that subset, because that is also in NetCDF file. But you can't even extract that stream flow for point data if you have the resolution like 0.25 kilometers. So you can only do that because these are the gridded data, and we are gonna use that gridded data right here. So that is the extent, and let me make the boundary, lower left corner, upper right corner. How can I do that? You can create one new rectangular shapefile that covers this area, right? So if you go to your home directory and your home geodatabase, go to new and create a feature class. And here, because we are going to create a polygon or rectangle, so the name is the boundary. Okay, that is the study area boundary, and I'm keeping the same name as alias, and then it's polygon. That's okay, and I'm clicking next, and that is WGS 1984. Next and next. So it will create an empty shape file. What do you have to do? Go to editor and click start editing, and then select that boundary, because we are going to edit that one. Okay, and then it is going to show you some options. You have to click continue. Then on the right side, you can see you have the create feature option. If you click on the boundary, it is giving you this option on the lower right corner: polygon, rectangle, circle, anything. So for this case, I'm going to select rectangle. Okay, so that is the easiest one, because if you select 2 point, it will just continue with that one. So I'm clicking there 1 point, and I'm clicking there as another point, just making it as a rectangle, perfect rectangle. Okay, that covers my area. And then if I go down, so it is covering my area. So double click, it's done. Okay, and now what do you have to do? Stop editing, and it will ask you to save. Yeah, I'm saving it. it's done. And if you want to just make it hollow, you can do that, and it is that one. So what you have to know right here, you can extract this way, right? You can just click there, right? You can click there and you can see the latitude and longitude there. You click there on the right side and the lower right corner, you can see there it is changing wherever you are moving your cursor or mouse, so mouse pointer, it is showing you the latitude and longitude. If I put it here, because I need this point and the upper right corner, so only it will cover the boundary box, because if you go this way, the latitude is same, right? The latitude will change, but the longitude will be same. And if you go from left to right, means from east to west, your longitude will be changing, but your latitude will be same. So we have one latitude this way, we have one latitude this way, we have one longitude this way, we have one longitude that way. So I'm clicking there and I'm writing that, okay? And before going to do that, I'm editing at the same time the code I have. So here it is. I'll just show you sequentially. So here I have the code and I'm just locating, okay? I'm just importing the NetCDF4 as before, right? I already mentioned that how to read NetCDF file. If you don't have idea, so you can watch the previous video, right? I have already demonstrated that one, how to read that. So you have to import NetCDF4, and in NetCDF4 we have the method to read any NetCDF file. It is called dataset. So I'm importing that one. Since I'll just do some processing in array, I'm importing that NumPy array if I need to. And since I'll deal with the time, because it also related to time, so I'm importing that time as well as time module. And I'm just suppressing some warnings this way. You don't need to do that, but you need only the upper part of this code. And here I'm just specifying where the file is located. Okay, let me just find the file where I have that. Probably it is there inside that one, and let me find it. So it is hwarp, right? It should be somewhere in between there. Hwarp should be here, right? It should be here. It is a NetCDF file. That one, wind and pressure. So how can you extract the link? You can go to there and you can click, it is only E, but including the name of the file, go to property and then security, it will show the full length. Okay, I'm just copying the full length and I'm pasting it there because we need that file name. Since it is Windows, so I'm doing this way. Okay, so that's it. And if you want to use the /, you can do that. Okay, I have the link of the file where it is located. Now I have to specify my boundary, right? The latitude boundary and the longitude boundary from minimum to maximum. For longitude it is opposite. See, 84, the value is maximum, but since it is negative, then that's why it is a minimum, from minimum to maximum, and that is from minimum to maximum as well. And now we need the GIS, and here if you click there, it is gonna show you that 28, the second one. See on the lower right corner, you can see that we are focusing on the latitude first. Okay, it is giving us 28.96, so we can use even 28. Lower is better, right? If we want to increase that, see, if you go that way, it is going to increase 29. So you can use 29. Okay, we can use 29, not a problem. 29 is okay, but here it is, we can use 28.9. It's better, 28.9. So that will be 28.9, 28.90. Okay, and what will be the other one? The maximum, it will be there, or it is there, it is same. The boundary, it is 30.85. Okay, we can go with that one as well, 30.85. okay, 30.85. And what is the boundary of that longitude? And that's it. You can even select there, that is the maximum value, and you can go that way, that is the minimum. So here is a minimum, minus 96.28, minus 96.28. There it will be negative 96.28. okay, and what will be the other one? I can remember that one, it may be 93, or let's check the decimal degrees as well. So that one is 93.88, okay, or 87. We can go with that 87 as well. So we have the boundary. So now, because it is covering the entire Atlantic, part of the Atlantic, and basically the half of USA, so I don't need that because my study area is located somewhere there. It's pretty tiny. I need to exclude all this, right, hassles, because I don't want to even, because this data is pretty big and it will it's high resolution data, so it will kill your space, and sometimes it will show some error that you are out of memory. Your computer can't handle that array because we'll do some array operation, right? So that's why I'm just making that subset. So we have the boundary. We are doing the same thing we did, right, to read any NetCDF file. What I'm doing, I'm just I already have use that data set command, the method, and I have that data object, and out of this data object I'm calling the name of the variables, right? I'm reading the variables at lats, I'm reading the variables as long, and also I have the time variable, right? I'm just making the total length of the time because I'm extracting everything. I know we have 38 steps. And then what I'm doing here, I'm just calling the minimum latitude because I know, right, this one, and I'm calling here the minimum argument, right, the minimum lat. So what I'm doing, I'm passing that boundary here. So that's where the first one, and it is taking a difference from that latitude, right, and from the upper part it is also making the difference, and it is calling the value. That is the command argmin. So argmin will give you the index, okay, index of minimum value, and argmax will give you the index of your maximum value. So that's why I'm making the difference. I'm just trying to catch the value. So the same logic I'm using here that I use for extracting the time series from a NetCDF file. If you haven't watched that video, you can go back and check. So that is the logic I used here. I'm making the difference in between all this latitude, right, within that NetCDF file and the latitude I'm giving here, and I'm trying to extract the index of that latitude from the NetCDF file which is close to my point. If these 2 points are superimposing, then the difference will be 0. It will be the minimum. If it is close to 0.1 and it is the minimum, so we'll consider that value as 28.9. And similarly, I'm just doing the same thing for other stations as well. So this is how I'm getting the minimum or the index of 4 points, 4 corner. And once I have that index, so I can easily, right, extract the values from those corners. So that is the logic I'm using here in order to make the subset. Now I'm making the latitude and longitude boundary, right, from that data file, because these points may not be the same point for the NetCDF file. So that's why we are just assuming or just getting the closest point, right, or closest boundary point. So that's why we're using this logic here, and I'm making this boundary. It's pretty simple, that from this latitude lower boundary to upper boundary, and I'm specifying this one, and I'm getting all this latitude and longitude from that NetCDF file because I'm subsetting, I'm excluding everything. Once I know the boundary of our index, right, and we can extract that one. So that is what I'm doing. So I know the index here from the NetCDF file, not from my latitude and longitude. I'm giving the latitude and longitude. I'm taking the difference and I'm asking, okay, what is the index of that point? What is the index of this point, that point, and this point? Once I have that, I'm now, okay, getting all this latitude from this one to that one, and all the longitude from this one to that one. And at the same time, all the values in, right, within this boundary box. So that is what I'm doing here, and I'm writing some, and here we can write the same, where I'm gonna save the file. Here it is in E drive. I can copy that. It will be also there, okay, E drive. And what will be the name of the file? You have to specify. Now I'm creating an empty NetCDF file. This is how we write NetCDF file. So it will be like that. It's in E drive, and so I can use today's date. And since I'm just extracting this data for Florence, Hurricane Florence. So I'm gonna use that. So today's date, I'm using that date, and let's see. And the format will be NetCDF 4 as well. And I'm opening that file as writing mode, not the reading mode. So the first one I use that see as reading mode because I was reading the main file. Now I'm opening a new NetCDF file, empty file, and it is in writing mode so that I can write the values right in that file. Then I'm just giving file description because it is the pressure Florence and reduced to mean sea level, and I'm subsetting. I'm giving this description, whatever you want, you can do that. And I'm just creating, okay, when I created the file, I'm okay giving this history. So there are some options, right? You can add the description file, anything you can add. And now what I'm specifying here, I'm just creating the dimensions of the new variables. What will be the dimension? Because previously we saw we have like 3200 columns and rows, right? So here, how many dimension, how many columns and rows we will have, because it depends on the resolution of the data. That's why we're extracting the minimum latitude and the maximum latitude and longitude, and within that one will will calculate. That's why I'm taking the difference between, see, the lower left latitude and the upper latitude. Then I'll have the number of value, so that is the dimension. Similarly for longitude, it is same, right? And what I'm creating now, I'm creating that dimension. Once I have the number, I'm creating the dimension. That is the command to create, right? The file name, because I'm opening the file as writing mode as file underscore my underscore file, and I'm using that file name and create dimension, and then I'm giving the name of the dimension long, and I'm giving the number of the dimension. Similarly for latitude and similarly for time. Okay, and for time I'm not giving any dimension. You can add as much time step as you want, because that is the third dimension. It is third dimension means the time dimension. You can go that way, keeping the boundary same. The main boundary is the spatial box, but the time is in the vertical direction for this case. You can go all the way to the infinity. Okay, and then here creating the variable to be written in the new file, right? So these are the variable, and I'm creating, that is the dimension I created, and now I'm creating the variable name. So for the time, create variable giving the time and the type of the data. It is a float 32, and it is also the time, and I'm giving the unit. Okay, so that is the times, and what will be the unit? The command is units times dot units, and I'm giving the days since this one. It is the same unit, right? I used. You can read the NetCDF file. You can use the same unit, time unit, and every other unit, because we are just making the subset. We are not changing the variables. We can change that. That is another history, but for this case, we're just making a smaller domain, not changing any values or dimension or type of the data. And I'm just exactly using the same types and data and everything. I'm just creating the variables, and units are same, degree north, degree south. And then what we need, our main variable is the pressure, right? I'm creating another variable, and then I'm giving the name as P, because in the main file is also the P, atmospheric pressure, and that will be 3 dimension. The first value will be time and the latitude and longitude. Okay, and that's why we are using the field value if there is any empty or missing value. So I'm using this field value. You can use that, or you can use any other value you want. And for U wind and for V wind, it is the same command. These are the 3-dimensional data. At first it will be the time, and then latitude, longitude. You can change the order as well. It doesn't matter, right? You can even put longitude first, latitude second, and time. That is the general thing that we use: time, latitude, and longitude. So that's the common convention we use, and the unit as well. Whatever unit you want, you can specify your unit by that command, the variable name dot units. And then I have the empty NetCDF file with those variable names. Now what I need to do, I need to fill up those variables with the actual values, right, from the main NetCDF file, but within that boundary box. So in order to do that, what I have to do here, see, I'm just filling up that latitude and calling what? Because I already mentioned that is the variable name latitude, and it is empty now. So if I use latitude and then that square bracket and colon means all. So I'm subsetting that latitude, right? Subset. I did it here. I just mentioned that one, it is there. I created that boundary from lower left to the upper right. I have the boundary, and I'm just adding all this thing for longitude, all values I'm adding. So this is simple for latitude and longitude, but for times and for other variables, what do we need to do? Because these are the three-dimensional data. So we have to loop through each of these times because we have 38 time step. So I have to loop through 38 times and I have to extract the values of P, U, and V, and I have to add those first. And then I have to go to the next time step because that will be superimposing to one another, right? It is kind of a layer. We have one layer, 0 time, and I'm adding another layer on the top of that, and I'm adding another layer. So this is how the dimension or the file, right? It arranges in the NetCDF file. So you can check for that one how it works. It is pretty simple, but it is pretty convenient to store a lot of information within small, right? Storage, and the format is pretty good. That's why it is called scientific. All this scientific data basically they store as NetCDF file, and it's pretty convenient if you know the command and if you know the operations, you can do that. And what I'm doing, I have 38 times, so that's why I listed the times here, right? At the beginning I have the times variables there. You can see I have all these times, right? It is there, and I already have the total time step. I know the total time step. What I'm doing here, I'm looping through that I and val because I'm reading those exact values of the files of the times. Okay, so if I use only that for val in times, it will give you the values, but I need the index at the same time, index and the value. So that is the command I and the value. The first one is the key or the index, and if you enumerate, use the enumerate command built-in function, then it will give you the index and the values as well. So the first one will be the index of the list, and the second one will give you the value. And I'm reading the first value by its index, right? I have every values of the index within that times variable, and I'm getting the first value for the first index, and I'm writing that right inside my times variable. I specified the variables here, empty variable. So whatever the time is in the main file, it will be there in the subset. And I'm also adding the same way for pressure, E wind, V wind. Okay, the first one will be the first index, first time index, 0 for the case, for this case, but it will add all this latitude and longitude for that time. So that is the command. Okay, it is, I'm giving the I and the latitude boundary from lower to upper and from left to right, and it will add all those latitude and longitude, means all those P values, not the latitude longitude, but I'm specifying the boundary of the latitude and longitude. So this is how it is written in the variable P, right? If you give the latitude and longitude and the time, then it will give you the pressure value, not the latitude and longitude. We added the latitude and longitude using different command. It's already done. Now we are dealing with the variables here, and we have the U wind and V wind, right? For first time step, it will be 0 time step, and it is going to add that time, and we're reading the values, all values for those time steps, right, within that boundary. That's why I'm assigning that boundary. And once it's done, it will close the reading file, data file, and it will also close the file that I just wrote here, right, as a NetCDF file. So let me quickly run it, if it works, if everything is okay. If we have values within this range, it won't show you any error. Otherwise, it will show you error if it doesn't have any values within this boundary. Okay, let me quickly run it. Let's see if it works. Yeah, maybe see it's working. On the right side you can see the console. It is, see, it's done. See, pretty quickly it's done, because 38 I just mentioned all these steps. See, it's pretty quickly it's done. At first what it did, it just opened the file, it's showing the variables and everything, and then quickly it's done. And if I open that directory, definitely I'll get that Florence, the name, the date and time. It just created this one, this file, the bottom one. Okay, and let me open that using panoply, and we'll compare that. Open, and what is the name of the file? It was Florence, right? Kind of starting with F, So that one, today's date, and I'm opening it. That's it. See, we have the same variable, latitude, same. Now I have the values only 160 and 130, but for this one it was like 2761. It was only 3241, but here it just subsetted this data, and the pressure value, everything is same, right? The PA, I'm changing the unit and time, I have everything, right? See, E wind and V wind. If I plot pressure again, let me just plot it. See, we have the value. Can we see that? It is there. See, we have the subset there, nothing else. I'm fixing the proportion, and I'm just, so that is the boundary I can show you. That's it. And if you want to see if it is really superimposing your area or not, even we can check that. How can we do that? Since I have this shape file here, I can even extract the shape file. I don't know where it is, so I'm just trying to export it again, and I'll add that. Let me show you there. Maybe it's gonna be there. Okay, Galveston. Okay, Galveston. Okay, and where it is gonna be NSD, and then inside the snapshot 7. Okay, or I can even go back, and I can even go back and data download, and I can put it there as well. I'm gonna create Galveston. Okay, Galveston. So inside that one it will create, and I'm gonna add that one. Okay, yeah. Oh, yeah, I can add it, or I can exclude that one. That is not a problem. Let me show you if it is really subsetting our data or not. That is the idea I need. So what I have to do, I have to use that overlay, right? That overlay, we have to use that overlay there. We have to add that file. So I'm gonna open that from, let me show you if I can find there. Definitely it should be there inside this file, and data download, and then Galveston. Yeah, that is the shape file I can show. So it is showing, should I import as overlay? Yeah, okay. So that's it. See, you can see that pretty quickly, right? It's definitely showing that one. So this is how we can subset. Okay, we can subset our data, and we can make anything. So that's it. It is pretty simple, right? And pretty interesting. We had a data that is covering entire USA. So what we did, we created the subset from this to that. Okay, I'm just placing that side by side. See, this tiny location, you can see that it is pretty tiny location here in Texas. And that's it. So if you wanna do this type of processing in your research, right, or any other task, you can follow this one. Maybe this will help you, because I was trying to do the same thing previously. I didn't have that idea, but when I need it, right, so I had to do it. There is no way, I needed to do it, and I did it finally. Okay, so thank you very much for watching, and you can try by yourself, and see you in the next tutorial. And if you have any query and question, you can make your comment, and if I need to improve anything, I'll do that. And if you need any help, I'll try to provide that suggestion if I know that. Otherwise, I'll try to figure it out by myself. And I think you people, you are smarter than anyone, I guess, and you can do that as well. So thank you very much, and see you in the next tutorial. Okay.